So the next thing we're going to look at is reducing fractions. Reducing fractions is basically writing the fractions in its most simplest terms. So for example, 2/4 is a perfectly good fraction. However, it's much easier to understand as 1/2. In the same way that 1/28 over 256, this is also a perfectly good fraction, but in reality, 128 is half of 256. This is a much easier number to understand. So we say that this is the fraction in its simplest form, or the most reduced form, maybe is a better way to say it. So we're looking to reduce a fraction. Now the quickest way to reduce a fraction, for example, if we take 48 over 20, the quickest way to reduce a fraction to its simplest terms is to find the greatest common factor of both the top and the bottom and then divide that out of each. So for example, for 48 and 20, 48 is 2 times 2 times 2 times 2 times 3, that's its prime factorization. 20 is 2 times 2 times 5, that's its prime factorization. So if I'm looking for the greatest common factor, it's 2 times 2, which is 4. Now again, you probably could have figured that out in your head, but it's nice to have this process to go through to figure out the greatest common factor if the numbers are in fact a little more difficult. So since the greatest common factor of this is 4, that means I should be able to divide a 4 out of each of these numbers. So 48 divided by 4 is 12. 20 divided by 4 is 5. And in fact, 12/5 is a reduced version of 48 over 20. It's the simplest version, and the reason I know it's the simplest version is because there are no other numbers that divide both 12 and 5. So when you're reducing a fraction, that's how you know you're all the way to your reduced terms. If you look at both of the numbers and there's no other numbers that will divide both of these numbers evenly, except for, of course, 1, because 1 will always divide into any number. Now the nice thing is, if you didn't realize that 4 was the greatest common factor, you could still do this problem. It would just take you a few extra steps. For example, if I had started with 48 over 20, I might notice that 2 divides into 48 and 2 also divides into 20. That works fine here. So I can divide by 2, divide by 2, so I'll get 24 on the top, 10 on the bottom. This is a reduced version of this. However, it's not the most reduced version because, again, I can say, well, 2 also divides 24 and 10. So that means I could actually do this a second time. 24 divided by 2 is 12, 10 divided by 2 is 5. And in fact, by doing this process twice, I've gotten down to the reduced form of the fraction. So you don't always have to use the greatest common factor. If you do use the greatest common factor, it's the fastest way. But if you don't realize what the greatest common factor is, you can just pick any factors and start dividing out. But the process is that you have to continue to do this until you can no longer divide a number into both of these. And if you notice, these always have to be exactly the same. You can't have a 3 and a 2 or a 5 and a 7. They have to be the exact same number, and you have to do this as many times as you can. So I might take another example would be something like 125 over 600. In this case, I notice maybe I don't want to go through and find what the greatest common factor is. So in this case, I just notice that 5 is definitely a factor of both. 5 divides into 125, 5 divides into 600. So I can divide this guy by 5 and this guy by 5. 25 divided by 125 divided by 5 is 25. 600 divided by 5 is going to be, oops, not 30, 120. Okay. So I asked myself at this point, is this the most reduced I can make this fraction. Well, no, because there's still a number that will divide both of these. 5 will divide both of these. Okay. So 25 divided by 5, okay, that's 5, so that's good. And 120 divided by 5. Is going to be 24. So at this point we can stop because nothing will divide both into 5 and into 24. Now what you'll notice here is that I divided by 5 twice. That means that I could have actually done this faster if I divided by 25, because 5 times 5 is 25. But maybe I didn't see that initially, but that also tells me that the greatest common factor would have been 25, and in fact, if I had realized that, I could have done this much faster. But sometimes we don't always realize what is the biggest number we can pull out at one time, so in that case, it's fine to do it in smaller steps, and eventually you will get to the answer. And let's do one more example that has a fraction mixed in with it. So that has a whole number mixed in with it. So 3 and 18 over 48. The only thing we have to reduce is the fraction part. The whole number part doesn't need to reduce at all because it's just a whole number. So really the only thing we're reducing is 18 over 48. In this case, 6 divides into each of these. So 18 divided by 6, 48 divided by 6, I'll get 3 over 8. So that means that I could have written this as 3 and 3/8. Now, if you had not realized that 6 goes into both of these, but you had realized, so this is another way, maybe you said, oh, both of these are even, so I know that 2 goes into each of these. So you would have ended up with 9 over 24. This is perfectly fine, however you have to keep going, because now I see that, oh, 9 and 24, actually I could divide each of those by 3 as well. And 9 divided by 3 is 3, and 24 divided by 3 is 8. So you'll see, you'll get to the same answer. It just so happens that 6 was the greatest common factor. And so when I divide by the greatest common factor, I can do it in one step. If I don't have the greatest common factor, I might have to do it in 2, 3, 4, many steps, just depending on the problem. So the good news is if you don't realize this is the greatest common factor, you can still get to your number. You just might have to take a few extra steps.